Well, I'd like to also introduce my co-presenter, Kim Bitsaros. Kim is from industry, and she's been co-teaching this course with me for over 5 years, I think. The reason we've included Anita and Cosette on this title slide is because a lot of what we're going to talk about goes back to prior to 2019, when a lot of changes to the course we're going to talk about came about through our learning things from Cosette and then more recently from Anita. So that's been a great and ongoing learning path for us. So that's essentially what we're going to talk about. And as engineers, this is going to be a little bit quantitative partway through the presentation because we want to kind of assess whether what we're doing is valid or not. So just to put it into set the stage, much of what we're going to say might be a little similar to what Sabrina presented, and I'll try not to repeat things that she's already discussed and brought about. This is about a design course, and it's a design course which is taught in the fall fourth year semester. It is also the first time the students do such a design course, and by that I mean a course where students are given a project. They have to work on this project in a team all semester long. They have an industrial mentor appointed to work with them and help them out. Sometimes this mentor may be us, sometimes it's somebody outside who might have suggested this particular project. The students have to come up with a solution for this problem. And the issue we try to stress to the students, it's not whether the solution is right or wrong. It's the process they go through to make decisions and to apply judgments, because that's what's really critical for engineers to learn how to do. And so we constantly try to guide them through the different stages of developing their project. And each of these stages is broken up into essentially almost half of the semester, where we try to indicate to them the various tools they need to be able to build their project step by step. We have built a series of case studies that are simpler problems that each group takes. And each group, by the way, is about 5 or 6 students. These case studies are simpler problems that can be addressed in a similar way to their bigger project. And they work on these during the class time, while in the seminar session, which is a 3-hour period, we meet with every project team and discuss their own particular project and their progress in those areas. I won't go into the details of how we monitor student progress, student engagement, but we have a lot of these tools on hand to monitor student interaction, student participation in the project, and as well as student level of depth and quality of work, as well as depth of work in each project. This is a very challenging scenario for students to tackle because they've always done classes where the professor lectures, they do the lectures, they do the assignments that they're given, they hand them in, they're graded right, wrong, and that's what they're used to. And so this is a completely different paradigm, and it takes them a while to get used to it. So we basically build these case studies to help them do that. The comments we're going to talk about stem from pre-pandemic period, pandemic period, and then hybrid period. So we're going to talk about results of the way we've done things in 2019, when everything was in person, 2020, where everything was online, and then 2021, when things were done in a hybrid format. And so one of the things we did during the 2020 online, we taped all of the interactions that we had. We gave the lectures that were part of the lecture period. We gave them online. We recorded them. We subsequently edited the lecture portion because a lecture of about 90 minutes, part of it was telling the students what they were going to do, and then part of it was having them work on the case study. Part of it was then bringing the class back together again with every group talking about how they handled their case study, and then taking the last 10 minutes or so to bring everything together. And that's when really the in-depth learning really takes place, by trying to compare and contrast different approaches that different groups took. So we took the first portion, edited the first portion, and set it up in eClass in 2021 as a video textbook, and asked the students to look at those video textbooks before they came to class. We give them a 5-minute quiz to make sure that they've seen the video. That was sort of a small gimme as part of their grade. And then engaged into the case study discussions, and then the presentations, followed by the summation at the end of the class. And this gives us more time to do the summation at the end, as opposed to what we did initially. That's the only change we really did to eClass, to our eClass course, compared to other years. We do have a section in eClass for students to give us feedback, and then we've set it up class by class, and it's done anonymously. And I don't believe I've ever received any during semester feedback from any of the students. All right, so our expectation is not so much, we want to see what the students have learned, or what the students are learning from this course. And in engineering, we have 12 accreditation criteria that all our graduating students must be able to meet in order to graduate, and in order for our program to be accredited. So we've basically set these up as a self-assessment scenario, where students are assessing themselves whether they are ready to graduate or not. And we do this test, or this quiz. We give this at the very beginning of the course, almost the very first class. We do this in the middle of the course, and we do this at the very end. So these are assessments that the students do. They do them anonymously. They provide feedback, comments, and we basically see how the students have assessed their learning in this course as the semester goes on. And you'll see results from the key aspects of the criteria that you see listed 1 to 12 on the right. You will see that from comparing 219, 220, and 221. All right. So what we have been trying to do in 2021 is incorporating a hybrid format, with some students online and some students were in person. We did try to do this so that it was flexible for the students, whether they were online or not. We try to be aware of who was online, how many were online. We often ask them direct questions of those that were online, and ask them to engage by always having their cameras on, and when they spoke, their microphones on. Incidentally, we have 2 teaching assistants in this course, and our teaching assistants participate in the class as well as in the seminar sessions, and they help us monitor questions and issues online. So we're basically a team, including our video tech. So we're a team of 5 that are in this course, and we've got usually around between 30 and 40 students in the classroom. We emphasize to the students that they need to take risks, but that's where the learning takes place, and it's not important for them. It's not important for their grade if they get the right answer or wrong answer. It's the process and the judgment that they apply. The laboratory time or seminar time is time dedicated to their specific problem, and we discuss with them what their progress is like. Now, this meeting is one where we conduct it as a way that is akin to a professional meeting. So students have to choose one of them in the group to be chair of the meeting. One of the students has to be the secretary of the meeting, and those roles have to rotate amongst all of them throughout the semester. So everybody gets to do that particular part and practice their leadership and support skills. And all these records are available to all the instructors throughout the semester. They also rate each other in terms of how well they have contributed week by week to the projects and to the project work. All right, now how do we measure whether we manage to reach the students and have them achieve success? And here, resiliency is critical because the students are going to always will hit a brick wall. They need to learn from their mistakes. They need to adjust their paths, and we try to help them with those tasks. We only step in primarily when they're trying to what we call push a rope. You can never push a rope. You can only pull on a rope. And so if they take a path that is impossible from an engineering perspective, we stop them and we try to get them to change direction from going down that path. Some groups are very stubborn, and sometimes they still want to go down that path, and they discover that that's not going to work. So the process is one where they take these self ratings, and at that point, I think I'll pass it over to Kim to talk about these ratings. I don't know if everybody's colorblind. We try to address that. We're using different colors. So the blue is the results, average scores on a scale of 1 to 5, 5 being superbly well prepared, and 1 being, I don't know anything about this topic. So these are the 12 criteria for accreditation. The blue is the scores, average scores at the beginning of the semester. The black are the middle, and the pink are those taken at the end. And this is just an example of the scores and the way that will be shown for specific criteria later on. You want to take it away from here, Kim?
So what I'm showing you on this slide is comparing the way students rated themselves year over year at each point in the semester from 2019 to 2021. And what we see by the end of the term, so that's the third bar in each case, the shaded one, is that there's not a huge difference in how they figured and how they self-rated themselves in engineering design. Next slide, please. This is where we're looking now at their knowledge base. And what we found again is a little bit of a difference between 2019 to 2021, the end of the term. But at the beginning of the term in 2021, they rated themselves as having better knowledge base than they did in 2020 when we had to be all online. So these guys had experienced that emergency learning the year prior, and they didn't feel as comfortable coming into our class when they got there as they did compared to other years. On the next slide, we look at problem analysis. And this one was really interesting to me in that 2019, at the beginning of the year, they thought they were pretty good at problem analysis. Same coming into 2020. After experiencing online learning, they didn't feel comfortable coming into our class looking at problem analysis. By the end of the term, they felt they achieved a really high score, 4.3 out of 5, on their skills in problem analysis, similar to what they felt like in 2020, an increase compared to full in-person learning from 2019. The next slide is what I call their self-view of functional work skills. So this is how are you able to function individually and as a team? What a difference we saw from in-person in 2019 to online in 2020, and then to settling in between somewhere in 2021. How does those changes in course modality actually have them viewing themselves in terms of being a team player and how well they worked individually? The next one looks at, this will be slide 15, at economics and project management. What we saw a huge increase in here, and again, year over year, was how good are we at managing our projects. So 2020, they were forced to because we were fully online. We get to 2021, and we have a huge increase in the learners' self-evaluations of project management skills. The next slide is the one that I'm particularly interested in, and this is lifelong learning. As engineers in a technical environment, we are constantly performing lifelong learning activities. I can't rely on what I learned 20 years ago as an undergraduate student and what I do every day. In fact, it has nothing to do with anything I learned. But what I see here is that at the end of each of these terms from 2019 to 2020 to 2021, we're seeing a year-over-year increase in the students' self-perception and their collective rating as having achieved lifelong learning skills. This is really reassuring to me when I hear in the media and I hear in education all of these people talking about the loss of learning and learning losses, and we're not getting there. But we actually didn't see that. Our students built this resiliency into being able to achieve those skills despite the challenges they were faced with. And I think that is so reassuring. And I feel good sending these engineers out into that professional environment, looking at how they're perceiving themselves. If we go to our
Just jump in, Tim, for a minute, for a quick minute here. I think it's important to also identify the fact that the students that were in the hybrid class of 2021 had already been through a year and a half of online learning. So that was their background coming into the hybrid class. And I think that is an important element in the improvements that we saw in the scores that we're seeing.
Agreed. I agree with that. So let's look at what does it all mean. Let's move down to our conclusion slide, and let's talk about what does this mean. So one of the things that we find in our course, so Hani, just 2 slides down, is that it's really important, and I think Sabina said this too, is we set up those expectations. Day one, what can you expect in this class? Every single class now requires them to do those active learning case studies that Hani was mentioning. Sabina also says that's what she does by doing demonstrations and problem solving in class. It's that active learning that really builds that learner motivation when we look at design courses, when we look for that higher level of thinking. What I really like to see is that all of those resiliency outcomes, or those what I call the key performance indicators for learners, they either held fairly constant or actually increased in the online and hybrid environment. And I was surprised to see that. One of the really nice things that happened for us in online and in hybrid is actually those SSRIs where the students are rating their instructors at the end of the term, which is always sometimes you get your feelings a little hurt by those, is we actually increased them when we went to online and in hybrid. So I was really excited to see that. So something we did worked, something we did really, really resonated with these students and helped them build that resiliency. One of the things going forward in our undergraduate program is that we're going to work to recommend adding an active learning course very early, first year or second year in our program, because we don't have it. This is our course in 4th year really is their first exposure to this real active learning environment that's sort of reflective of what we do in industry. And so I'd like them to build these skills earlier in their careers and become more resilient as they move through our program.
I think the critical thing, I think the thing that we think qualitatively, it's our gut feel that is really different between the 3 years, is that the fact that the students were online for a year and a half due to COVID, they learned how to be resilient. And so they had much more resiliency coming into 2021 than previous students had coming into this course. And so I think our conclusion is that every academic program should have at least every year of the academic a course where students engage in active learning and helps them build that resiliency more and more every year until they get to their fourth year. So and with that, I want to, on behalf of Kim, express our thanks to Anita and to Cosette for all the hand-holding and the patience that you've helped us with throughout all these years. Thank you.
Oh, there was no hand-holding. You are all just such magnificent instructors. My heart is full just having you here.